Hello, in this video we're going to learn how to graph linear equations using the form y equals mx plus b. This format, y equals mx plus b, uses the slope and the y-intercept. So m refers to the slope and b refers to the y-intercept. Now the y-intercept means where does it hit the y-axis. So in this case, the first example, y equals 1/3 x plus 2, the y-intercept is plus 2. The slope is 1/3. Now before we go on, let's talk about what the slope means. Slope is defined as rise over run. And when we say run, we mean run to the right. So slope, if you have a positive slope, we're going to rise and then we're going to run. So from any point on the line, you can rise a certain amount and then run a certain amount, and then you can get the next point on the line, and then you can connect those points. Now that's for a positive slope. For negative slopes, we're actually going to be going in another direction, but we'll cover that in another example. So let's take a look at our first example. Y equals 1/3 x plus 2. The very first step we want to start with is looking at our y-intercept. Again, in the y equals mx plus b format, this is b. b is plus 2. So we're going to start here on the origin, and we're going to count up 2 spaces, and we're going to put our first dot there. Put a nice bold dot at plus 2 on the y-axis. Again, here's your y-axis and here's the x-axis. Now that we've placed our first point, we're going to count in increments of the slope. And the slope is 1/3. So we're going to rise 1 and we're going to run 3. So let's just start at this point. We're going to rise 1 and we're going to run 3. 1, 2, 3. And we're going to plot our second point. And now we've just got 2 points, and it's always good to count in several increments of the slope. Rise 1, run 3. 1, 2, 3. And the thing is, if you're familiar with how you move a piece on a board game, then you can move rise over run. Don't count the first square. For example, if your point is here, don't say 1, 2, 3, because that's only 2 squares. So if your first point is here, you can count 1, 2, 3. That's a move of 3 squares. Now we've got 3 points so far on our graph. You can also count in negative increments of your slope. So for example, if our slope is 1/3, we can actually count in a negative increment, which would be -1 over -3. Now that does equal 1/3. So for example, from this y-intercept, we can count -1, which means go down 1, and then we can count run of a -3, which means left 1, 2, 3. And you can count several increments of this. Rise -1, run -3. And this is going to be our line. So I'm just going to use another color here, and we'll just sketch this line in. Now, if this were a real piece of paper, you would use a straight edge. But I'm just going to sketch the line in. And it should be a razor sharp line if you've done the counting correctly. Now let's take a look at another example. Over here on the left, we've got y equals 2/5 x plus 1. And again, our first step is to graph the y-intercept. The y-intercept in this case is plus 1. So we start at the origin, we go up 1 step. And then our slope is 2/5. So we're going to rise 2, and then run to the right 5 squares. So we're going to rise 2, 1, 2, and we're going to run 5. 1, 2, 3, 4, 5. Now we're going to run out of room. If you had a big piece of graph paper, you would be able to count other points. But let's go to the left. And in this case, we're going to rise -2, which means go down 2, and then run -5. Again, you want an equivalent slope. So we're going to rise -2, go down 2, and then run -5. 1, 2, 3, 4, 5. And again, we can connect these with a sketched in line. If you had a straight edge, maybe you'd be able to do a better job of this. And so there's our line. Now let's take a look at this example on the right. We have a negative y-intercept. Our y-intercept is a -3. Remember, it's y equals mx plus b, but this doesn't say plus b, this is -3. So that means our y-intercept is a -3. So we're going to start at our origin, go down 3, 1, 2, 3, and place our first point. And then count increments of the slope again. Rise 1, run 4. Rise 1, run 1, 2, 3, 4. Now I can kind of fake it for another point. It's slightly off the graph, but let's do another point. Rise 1, run 1, 2, 3, 4. Slightly off my graph, but you get the idea. And I'm going to go in the other direction as well. Again, I can count in increments of the negative version of the slope. If the slope is 1/4, the negative version of the same slope is -1 over -4. So rise -1, run -4. 1, 2, 3, 4. Do it again. Rise -1, run -4. 1, 2, 3, 4. And again, we're going to connect up these with a sketched in line. So let's do a couple more examples. What if your slope is not actually a fraction? Remember we said that slope is rise over run. In this case, the slope is 2. So how do we say rise over run? Well, you just simply write that as a fraction, which is 2 over 1. So we're going to rise 2, and we're going to run 1. Now where do we start? In this case, we have a y-intercept of -1. So we're going to start on the y-axis, -1 on the y-axis, and we're going to count in increments of the slope, which is 2 over 1. Rise 2, run 1. Notice that this slope is much steeper. This is a steep slope. We're going to do it again. Rise 2, run 1. I've got lots of room to do several increments, so we're just going to count as many as we can. Rise 2, run 1. We can also go in the negative direction, which would be -2 over -1. So again, starting at the y-intercept, rise -2, which goes down 2, run -1, go to the left 1. And then repeat the increment. Rise -2, run -1. And your point should be in a nice straight line. So let's sketch a line in between these. You get the idea. Our next example has a negative slope. Now this is our first example with a negative slope. So just very quickly, let's plot in our y-intercept, which is +2. So here's the y-intercept. But our slope says -1 over 3. So we're going to rise -1, and then we're going to run 3. In other words, we're going to go down 1, and then we're going to go to the right 3. In other words, this is our first line that's actually going in a downhill fashion. We're going to rise -1, going down 1, and then run 3. And we can also go backwards. Now, what's the negative version of this slope? This would be a +1 over a -3. That's the equivalent slope. So starting at my y-intercept, I'm going to go rise 1, run -3. 1, 2, 3. And I can do it again. Rise 1, run -3. 1, 2, 3. And I can connect these with a sketched in line. All right. Now let's take a look at a couple more. Here is a negative slope, but this one again is not written as a fraction. So if our slope is -3, how do we express that as a fraction? Just -3 over 1. Now my y-intercept is a +5, so let's count upward. 1, 2, 3, 4, 5. Looks like I'm going to run out of room, but let's see if I can... no, actually I've got enough room. So here we're going to rise -3. Again, when we rise a negative amount, we go down, and then we're going to run 1. So we're going to count downwards, 1, 2, 3, rise -3, and run 1. Rise -3, and run 1. And count several increments. Rise -3, run 1. And I've got room for one more. Rise -3, run 1. And I don't really have enough room to do it backwards, but let's pretend my graph paper is a little bit long. Rise +3, run -1. Again, the negative version of this slope, same slope, but just with negative signs in a different place, is a 3 over -1. So I can rise 3 and then run -1. And then let's connect these with a sketched in line. You get the idea. Here's an example where the minus sign is just in front of the fraction, in front of the slope. And this confuses a lot of students. So please do not make the mistake of saying this is -2 over -3. This is not -2 over -3. Okay, this is not equal. What -2/3 equals, here you have a choice of how you're going to write your slope. You can either write it as -2 over a +3, or you can write it as a +2 over a -3. Now, no matter how you look at it, this still is equal to -2/3. -2/3. So I prefer to start with something like this, a -2 over a +3. So again, we start with our y-intercept. In this case, it's +1. So let's plot that point, +1. And now I'm going to rise -2, which means go down 2, and then run 3. 1, 2, 3. And I repeat the process. Rise -2, run 3. And here's a hint. If your slope is negative, in this case y equals -2/3 x plus 1, if your slope is negative, your line should be going downhill. And if your line doesn't go downhill with a negative slope, then you're doing it wrong. So let's count it in the negative version. So for example, +2 over -3. So rise 2, +2, 1, 2, and then run -3. 1, 2, 3. And we've got room for one more. Rise 2, run -3. And then we sketch in our line. And we've got one more example. Now, remember our pattern, y equals mx plus b. Now, m is the coefficient of x, so mx, here we have 1/2 x, but I do not see a plus b. So you want to ask yourself, what would make this equation equal to the same equation? Like, you can't just arbitrarily add. For example, I can't just make up a number like +1. That's illegal. What can I add that doesn't change the equation? I can add a +0. So technically my equation has not changed. Y equals 1/2 x plus 0. So that means that my y-intercept in this case is actually at the origin. So I'm going to stay at the origin. +0 is my y-intercept. My slope is 1/2, which means rise 1, run 2. And then I just keep plotting points. Rise 1, run 2. Rise 1, run 2. Or I can go in the negative direction, rise -1, run -2. So this is an upward slope. My slope is positive, but the y-intercept is at the origin. And let's sketch in a line connecting these points. So this is a little tricky because a lot of times students, when they don't see the y-intercept, they I don't know, they kind of choke. So just add a +0. That doesn't change the equation at all. Now, if you'd like, you want to be able to practice graphing linear equations. So I'm going to put some links up so you can practice these skills.